matter and energy, potential and kinetic energy, and calculating speed. Today we're going to compare and contrast potential and kinetic energy. A demonstration helps students understand the principle of a roller coaster design. Which answer choice correctly describes the ball's kinetic and potential energy? So remember, the greatest potential energy is when the object is highly elevated off the ground. So in this position, you're going to have the greatest potential energy because it's the furthest from the ground, but you have the least kinetic energy, energy of motion. Down here at this position, you have the greatest kinetic energy, energy of motion, and the least potential energy, stored energy. So, which answer choice correctly describes the ball's kinetic and potential energy? The ball has more potential energy at X than it does at Z. That's incorrect because Z would have more potential energy than at X because it's higher up. The ball has more kinetic energy at position Y than W. Yes, the ball has more kinetic energy at position Y than at W because when the ball is the closest to the ground is where it's going to have the greatest kinetic energy, energy of motion. That's where it's going to be moving the fastest. And let's look at C. The potential and kinetic energy of the ball are equal at position X. That's incorrect. Drag and drop the potential energy and kinetic energy cards from the bottom into the gray blocks in the picture below to identify each as kinetic or potential energy. So again, kinetic energy is energy of motion, so where an object's moving. Potential energy is stored energy where the object's at rest. So if we look at position 1, we can say this person is not moving, so he has potential energy. At position 2, this person is not moving, so they also have potential energy. Here, the swimmer, they are swimming, so we have kinetic energy, energy of motion. And then same here at position 4, we have energy of motion, so that's kinetic energy because they're hitting the volleyball. Drag and drop the cards from the bottom into the gray blocks in the picture below to identify each position as both the greatest kinetic and least potential, or the greatest potential and least kinetic. So here where the roller coaster is not moving and you're highest off the ground, so you're highly elevated, is where you have the greatest potential and the least kinetic. There's no energy of motion. So down here, when the roller coaster gets to this position, you're going to have the greatest kinetic energy, energy of motion, and the least potential energy. I can calculate the average speed using distant time measurements. The distance a toy car travels over time is shown in the graph. So which table best shows the average speed of the toy car at different time intervals? So remember, speed equals distance divided by time. So if we start with this, from 0 to 2 is your time. So from 0 to 2, that's 2 seconds, that's your time, divided by the distance it took. So 2 meters is your distance and your time is 2 meters. So 2 divided by 2 is 1 meter per second. So far A and D would look good. Then here between 2 and 4, so what you have is the time in between 2 and 4, so that would be 1 second. 2 seconds is your total time. And the distance traveled from there would be from here to here, which would be 1. So 1 meter divided by 2 is 0.5 meters per second. And then between 4 and 6, you see you're not going any distance, so your distance is 0 divided by time. So that would be 0. So A looks good. Okay, so we're going to use a calculator to calculate speed using the guess strategy. So our formula is average speed equals distance divided by time. So using our formula triangle, you would place these variables just as they read: distance divided by time, distance divided by time, and then there's your speed. Okay, so if a car travels 400 meters, that's your distance, in 20 seconds, how fast is it going? So this is your distance. This is what's given to 400 meters. The time it takes is 20 seconds. So distance divided by time, you would use a calculator and figure that out. Using the calculator, let's calculate the speed. So you arrive in my class 45 seconds after leaving math, which is 90 meters away. How fast did you travel? So again, how fast did you travel is distance divided by time. So your distance is 90 meters divided by time, which is 45 seconds. An airplane flies 2,720 kilometers in 4 hours. Calculate the average speed in kilometers per hour. So again, distance divided by time would give you your average speed. Mike rides his motorcycle 46 kilometers in a half hour. Calculate his average speed in kilometers per hour. So here's your distance divided by time. Just be aware when you have half an hour, it's 0.5. So distance is 46 kilometers divided by your time, which is 0.5. Okay, I hope you enjoyed your lesson today.